So one of my most viewed videos on YouTube is how I find shorts with test lights on cars. And I always get a lot of questions about it. And so I figured I'd make another video going a little more in depth, a little more in detail about the process and what I'm using to find shorts on cars. So this car is a Mazda 6, a 2007 model, and the problem it's having is this fuse right here keeps blowing every time the ignition is turned on. And looking at the fuse box here, we can see that the fuse that is blowing is this TCM 15 amp fuse. So right here, right there. So now we need to go to a wiring diagram and see what all this fuse feeds. We know from the fuse box this TCM is labeled TCM, but sometimes fuses feed other things. So right here I have the factory wiring diagram. This is for just power distribution is what they would call this. And the 15 amp fuse for the TCM is right here. So we've got battery coming straight into this fuse, and then this diagram shows it going straight to a ECAT control system. I'm sure that's going to be electrically controlled automatic control systems, probably what that stands for. This diagram is a little misleading. Even though this is the OE diagram, there is more in this circuit than that control module. So I've also pulled up the electronic transmissions diagram, and you can see right here we have this 15 amp fuse. It is fed by battery power, but when it comes out of the fuse box, it's actually going through an AT main relay, and then out of that relay is going to the TCM. It's got two connections to the TCM, a third one, or well, I'm sorry, I'm pointing at the wrong thing. It's kind of hard to do, look at through the camera at this, but we've got two connections here on the TCM coming out of the relay, but also this branches out to a vehicle speed sensor and then a intermediate speed sensor, which is in another diagram. And here is the other diagram where it's got that intermediate speed sensor. So by the factory diagrams, this fuse feeds two spots on the TCM as well as two speed sensors on the transmission. So that's four circuits really that this could be shorted to ground to. The wire itself could also just be shorted to ground as well. And we know the problem isn't between the fuse and the relay, because the customer stated that it only happens when you turn the key on. So these are the original diagrams, the OEs. There is aftermarket redrawn diagrams that you can also look at, and they're going to basically show the same thing. The power distribution aftermarket redrawn diagram shows this fuse just goes to the transmission system. That's all it's going to give us there. But on the transmission diagram, we have the fuse coming down and across over here to this AT main relay like we showed on the OE diagram, and then coming out, I've highlighted it to show all the circuits it goes to. So right here we've got the on transaxle vehicle speed sensor, and then down here we got that intermediate speed sensor which is on the transaxle, and then we've got the two power inputs to the TCM. So not really a whole lot on this that we need to really check, but that's four possibilities plus a short in the harness somewhere that we need to look at. Now I know that one of these legs in here is going to be fed constant battery power. I've got my meter set up here. I've got just my test light basically just back probed in with my negative lead, and right now I've got my negative lead on the battery negative, and then positive lead I just have a terminated lead. Now I just want to touch these terminals to find out which one is the battery power. So that one shows nothing. If I move over to this side, you can see the bulb is lit up, and there I've got my voltage. This battery is pretty dead, so I'm actually having to charge it with my van, but we've got 11.8 volts on this side on the left. So I'm going to just leave my lead in there. Okay, so my light bulb is lit. That is showing me that that 12 volts has a path from there through my light bulb to ground. Okay, surely that makes sense. So if I move my negative lead to the output side of that fuse, right now the key is off. You can see the bulb is off. There is no voltage because there's no current flowing. Okay, I'm basically sending power on my red lead through the light bulb, through the black lead to the output of the fuse right here. But since there is no path to ground, no current is flowing, and there is no voltage drop. So right here, there is 12 volts sitting here. But since it's not going anywhere, there is no voltage drop. We are measuring voltage drop right here. Let me get another test light and I'll show you. Okay, so here's another test light. I'm just going to go in the back of this. So this, let me try to spread this out so it kind of makes sense. I've got power coming in to my red lead through my bulb onto the black lead. Okay, so I have 12 volts sitting here waiting to be used. So my other test lead here, or test light, if I touch this to ground, you see that lights up? You see we now have a voltage drop of 0.2 volts. That means that this bulb is not consuming all the power. This bulb is consuming the power. Across this bulb, there's only a 2 volt drop. All right, let me get another meter and this will make more sense. So same thing, this meter has 12 volts coming in the red line through the light bulb. This is a 2 amp light bulb, through it onto the black, and you see we've got 0 volts here because we are open circuit. This current is not going anywhere. All right, the load, this test light, is not connected to anything. I have this meter with my red lead connected here with the black lead. So this is the output from my 2 amp light bulb. So I've got 12 volts sitting here because this meter is connected to ground. So 12 volts. If I take my test light and touch that, you see that dropped 11.8.2. That's the voltage difference. So if I undo this where it's open circuit, see how this is 0.2, this dropped 0.2? That's voltage drop. We're measuring voltage drop right here and seeing actual voltage right here. So I know this circuit right now is not doing anything. There is no current flowing right now. Let's turn the key on. All right, so I've got you guys where you can see the voltmeter here and the light bulb here. And I'm going to turn the key on, and that should turn the relay on here. And we're going to see this bulb light, and we're going to have a complete voltage drop across this bulb. You see, now we've got an 11.5 volt drop across the bulb. The bulb is lit, meaning it is consuming power. This tells me there is a significant draw right now going through the circuit. There is a path to ground through the circuit. So if I take another bulb, remember we're a 15 amp circuit, this is a 2 amp bulb. So right now the circuit is allowing 2 amps to flow because the bulb is limiting it. The bulb will only flow 2 amps of current. I can show that to you in just a second also. So I've got another bulb here. This is a H13 bulb, and this one can can either pull 5.1 amps of current or 4.5. So since this is a 15 amp circuit, I want to give it a little more current just to see real quickly if this bulb lights. This is a direct short to ground because OEs are not going to put a 15 amp circuit in there and then let you get really that close. They're only going to use about half the amperage of the fuse. So let's see if this lights up, and it does, real bright. So I don't want to leave that on too long because I have no idea where the short is, but that was allowing about 12 volt or 12 amps of current to flow through the circuit. So that is guaranteed a short to ground. If I put a fuse in right now, I have a good fuse here. If I put this fuse in right now, it would blow for sure, because 10 amps of current plus 2 amps, 12 amps, it's only 3 amps away from that, and we were still dropping 10 volts there. So that was a lot of current flowing, and I know that fuse would pop. All right, so now to show you that we're going to let 2 amps of current flow through this light bulb, through the circuit, to find this short, basically. So on my bulb here, it's a dual filament bulb. One of them I have 2 wrote on it because that's my 2 amp circuit, and one of them I have a 0.5 because this is a half amp circuit. So same thing, if I take power, we're going to use the half amp real fast. This is going to be on my power coming in from the fuse box. I know you guys ain't gonna really be able to see that, but this is power coming in from the fuse box. Is going to go through the bulb. Okay, so we've got 12 volts sitting right here. I'm going to attach it here. Okay, this lead isn't connected to anything. So actually, let's just take that out of the picture so it doesn't confuse you at all. My black lead is still connected to the output side of the fuse. So this is going to be going to the TCM. Well, it's going to be going through the relay to the TCM and the 2 sensors. So we have 12 volts sitting right here, and we're on amps. So if I put this into the amp side, you see this is lit, and on the meter we're showing 0.53 amps of current flowing through the meter now to the TCM. If I add my 2 amps to this, and this is getting a little bit of a loose connection in here, but if I add my 2 amps here, so this is going to be a total of 2.5 roughly. Reconnect this down here, and you see 2.5. So now there's 2.5 amps of current flowing through the circuit. That is how the bulb is limiting the circuit in the car. So wherever this short to ground is, right now it's flowing 2.5 amps of current. If I unplug this and only use my 2 amp filament, see we're at 2 amps. So right now the circuit is allowed 2 amps of current flow. I'll pick you guys up so you can see. We've got power coming in here through the 2 amp filament of my bulb, out of the bulb into the meter on the amp side, and we're on amps, okay, DC amps, coming out of the meter to the fused output side right here, which is then going through the TCM relay. Right now the key is on, so this is turned on, and this is supplying power now to the TCM, the intermediate speed sensor, and the vehicle speed sensor. And I also know this is the relay because if I pull this, let me grab my pliers here, and if I pull this out, that's going to go away. Okay, so I know this is my TCM relay, or automatic transmission relay. If I stick that back in there, the bulb lights back up, I have my 2 amp draw, pull that back out. There we go. So I'm going to actually put a fuse in here now. This is a good fuse right here. Stick that in there. So now I have power sitting here waiting to go somewhere. And if I just take my leads here, we're just going to lay these in here for just a second so I can show you. See, now we've moved. I've actually got my polarity backwards. So that's going to tell me that this pin is the output side and this pin is the input side. And I'm not spreading these. These leads are just barely fitting in the holes. They're loose, so they're just sitting in there. So there we go. We've got now power coming in through the bulb, through the meter, so we can see our amp draw, back through the circuit to the car. And we've got a 2 amp draw essentially right now because that's shorted to ground. Now that I know this is for sure my relay that supplies power, I can actually just take this out and I can move my testing to this. I can turn the key off and still pass power through the circuit. So right now this has 12 volts sitting on it because this is coming from the fuse in right here. If I take this and touch it to ground, you see our current draw there, bulb is lit there. And we can now place this back into the output here. And we have our short to ground test set up with the key off. All right, so now that I have it set up where we are showing the short to ground with the meter and the light bulb, my process would be to go through all the devices on the circuit, modules, sensors, things like that, and unplug them until I see this go away. If I unplug all the devices and modules and I still have this short to ground, obviously it's going to be in the wire, and I would break the harness down into connectors if I could. So like if there's a connector in line of a harness that I'm suspected about, I'll unplug the harness to see if my short will go away. If my short goes away, then it's on the further end of that circuit, downline of that connector, and I can focus more on that section. On this car, I've actually kind of already went through it. I already know what's wrong with it, but we're going to go through it again. And the easiest thing on this car to unplug that is on this circuit is the TCM. So spoiler alert, the problem is the TCM. So I'm moving my leads inside the car so we can do the testing in there and kind of show everything. So I've got my yellow lead here is on the voltage coming into the relay. The black lead here is voltage going out from the relay to the TCM and the speed sensor circuits. So constant power right here. This would be relay output, or the load side of the relay. All right, so I've just got them coming inside the car, and they're just sitting right here. So this will have power on it, and this will have a ground on it because this side is shorted to ground. So if I take this and just pin it into a voltmeter, you see 12 volts. Okay, that means right here I have 12 volts potential, but it is actually being used because I have a 12 volt drop across these leads. If I take the test light and we're going to go to the 2 amp circuit here, when you're on the inside of a car, be careful with these because they do get hot. They will burn carpets and plastics and stuff like that. So I always try to set it somewhere where it's either going to be hanging on my meter or something like that. But if I plug this in here, see, we've got a light, we've got that 11 volt drop here. If I unplug it, there we go, it comes up. So this shows we've got power and we've got a ground, a short to ground on this side, and we shouldn't have a short to ground on this side. What we're going to do is we're going to use 1 meter to do voltage drop, measure the voltage drop across the bulb, and 1 meter to see the current going through the circuit. Normally when I'm doing this, I'm really only using a bulb, maybe a meter, maybe not. If I know there's a short to ground, I'm not really using the meter. I'm just using the meter here to give you guys a reference so you can kind of see the correlation between voltage drop in the circuit and the current draw. So the way we're going to do this, we're going to send 12 volt power into the bulb. So right now I have 12 volts sitting here. Okay, if I plug that into there and then I give it this ground, you'll see we've dropped 12 volts. All right, we're not consuming power right here, but there's 12 volts there because my meter isn't allowing it to flow the current. All right, so we've just got 12 volts sitting here. So this lead, we're going to go into the output side of our current meter, and then we're going to, on our voltage meter here, we're going to go our negative lead and positive lead. Our positive lead is going to go in here with our 12 volts here. Our negative lead is going to go in with our output from the light bulb. And let's see. So right now, there is no current flowing. There's no voltage drop across the bulb. There's no current. If I take this and plug it into my current side, you can now see we're flowing current, bulb is lit, voltage drop across the bulb, and a current draw of basically 2 amps. So hopefully this makes sense. We're just, like I said again, we're just using the meters here to give a number value with everything. So I know that the TCM is bad in this car. This is not the TCM, this is actually the PCM. I don't know why this is pulled out, but the TCM is actually under the dash under here. So let me try to get to where I can show you that. All right, so this here is actually the TCM, and I know the power feeds come in on the top plug up there. So let me get up there and unplug that for you. And we're gonna see this go away. I have to try to do this without knocking the camera over. And this plug kind of a pain to get out sometimes. we go. So there we go. There, our short to ground has disappeared. Now we've got no voltage drop and we're pulling no current. Well, there's a tiny bit of current actually because the speed sensors that are still in the circuit, but they're pulling 22 milliamps. If I unplug the speed sensors, that would go away as well. And the speed sensors are only making a voltage drop of 0.2 or 0.20, I don't even know how to say that, 0.2 volts, so 2 millivolts, I guess that would be, or 20 millivolts. Yeah, that would be 20 millivolts. There we go. I'm terrible with these decimal denomination stuff. I'm sure somebody will comment and tell me what they are if I'm saying it wrong. But if I reach back up in here and plug the TCM back in, there we go. We got our short back unplugged. It goes away. Plug it back up. There we go. So the issue that we have is in that TCM or one of the outputs in this circuit here, if this has outputs. So we could test these. I'm sure some of these are going to be outputs, and I actually know what they are, but I think it'll be kind of cool to show you the outputs here with what it does here. Sorry about the noise. I'm sure you probably hear a tow truck in the background running, but over here I've got the harness that is from the TCM. I know it's barely in view, but this is the TCM harness. On the back here, I'll move you over here for just a second. On the back here, we've got the yellow and red wires. That's my 2 powers coming in. I've got 2 blacks right there that are grounds. And then these wires over here go into things in the transmission, like solenoids and things like that. Now I want to show you something real cool about using this method of a test light letting the current flow through it with a voltage drop. The current meter, not really important because the current's still going to show, but the voltage is going to be slightly different than what you're expecting. And it's a real cool test. So let me kind of set you up here. So now keep in mind, we're measuring the voltage drop across this light bulb, right? So we're seeing the difference in voltage of coming in and what is leaving this light bulb. So right here I have another test light. It's the same test light. I've got different colored ends on this, but this is still a 2 amp filament with the ground. And on my connector over here, I'm just going to go power in one side, and then I'm just going to go straight to the ground on the other side, and both of these bulbs are going to light. Okay, so you can see it's actually dimmer than it was before. Our current draw is now 1.3, so slightly lower than the 2 amps, but you see our voltage drop now is 5 volts, or 5.5. That means there's 12 volts going in, and coming out, it dropped 5 volts. What that's telling me is I've got some power being consumed here, and some power being consumed somewhere else. So if we undo this, and we're going to go straight battery to ground, or the power coming in to ground through just a jumper harness here. So just a test lead here with my 2 ends. So one going in to the ground, and try to get out of the way so you can see this. As soon as I touch this, almost 11 volts of drop, 2 amps of current. So that's telling me this bulb is using almost all the power that it's being supplied with. So how can we use that information? Well, what we can do now is jump from our power feed coming into this connector to the different solenoids, just to make sure there's not one of these power feeds basically just jumping through the module, going straight out to a solenoid, and then being ground side controlled. I already know that's not the case from the diagram. The diagram actually shows them being connected to ground. Let's see, right here. This is the ground to the solenoids here. And some other solenoids are internally grounded here. So all of these are actually getting a pulse width power switch from the TCM over here. So none of these are actually fed constant power or battery power or ignition power. They're controlled by the TCM, and then they're always grounded. So let's look at this, and we'll pick the shift solenoid A is A1, pin A1. It's a light green and red. And light green and red right here. So if I take and jump power from there to that solenoid, we're going to see a slight difference here. Okay. Did you see how this slowly brightened up? And you see how we've got 7 volts of drop? Still pulling 1.5 amps of current, but we've got a 7 volt drop now across this light bulb. That means this bulb is not consuming all the power. That's telling me something else in the line is consuming power, but it's not a direct path to ground, because if it was a direct path to ground, we'd be seeing closer to this 11 volts and closer to 2 amps of current. Now if we go back to this solenoid again, you see how that slowly brightened up? Do it again. We'll let that kind of go back off. Slowly brightened up. We could go through all these solenoids and test it like this and see if we have a voltage drop on each one of them that is similar. So that was A1. The other ones is going to be, let's see, a B, a light green and black. So that right there, 7 volts. And again, this is telling me there is some resistance in this circuit outside of this light bulb, which is a good thing. That means it's not shorted to ground. And then let's see, what's another solenoid here we've got? An orange. So this orange right here. There we go, 7 volts, 1.5 amps. This is gonna be the same on all these solenoids. I've already went through all of them, but I just wanted to give you an idea, like, you know, if you're wanting to test to make sure there's not something outside of this, this is kind of how you could do it. You got to pay attention to what you're connecting to, like being another solenoid. A solenoid is designed to use current, so giving it straight power like that through this test light, this test light is going to limit it to 2 amps no matter what. But you could also, you know, use another test light, like this is going to be a half amp current with this one at 2 amps. So my actual current limit is actually going to be 0.5 amp with this test light. So if I go battery power, and then we'll go to that orange one again. You see how we're limited to 0.5 amp here now? And the voltage drop across here is only 0.5 volt. That means there's basically 12 volts going in, 11.5 coming out, basically. And the circuit is limited to 0.5 amp. You could do this with any test light. Let me grab a different one. Like this test light right here is going to be about 1/4 of an amp. So we'll do the same thing here. We're going to go power coming into the bulb. We'll just touch this to this side, and you see we're limiting the current to 0.28 amps. So a little over 1/4 of an amp, and the voltage drop that's happening across this is about 2 to 3/10 of a volt. So if this had 12 volts coming in, it'd be like 11.7 coming out. So hopefully that makes sense, and hopefully this kind of shows you how you can use a test light to find shorts in circuits. I've got several other videos showing shorts to grounds and things like that, and this is my method that I always use. And if it is a harness issue, I do the wiggle test. You know, I've got a Allison video, Duramax with an Allison transmission, where I used a test light and wiggled the harness until I found the test light turning off, because that's what you want. You want the test light to go off. When it's off, that means the circuit is no longer shorted to ground and everything is correct. And you can do just wiggle test along the harness to find it in the harness. So hopefully that makes sense to you. This is more of an in-depth into the kind of the mechanics of how this works and kind of what I'm doing, what I'm looking at, and it may still be a little over your head, but just go with it. Just try it out. Once you get the hang of it, you'll understand it a lot better. And basically all we're doing is pulling the fuse out, putting a bulb in place of the fuse so the circuit can pass current. And we're using different size bulbs to limit the amount of current that can flow through the wire. One really cool test you could do is if it's cold enough and everything is turned off and it's set overnight or whatever to actually cool off, is I could have took that relay out and put my test light in there to pass 2 amps of current, and I could have went over the car with a thermal imager. I could have looked at the sensors, I could have looked at the TCM and seen which device or whatever is consuming the power. You'll get hot spots, and if you're really lucky, you can also see it on a harness. If a harness is chafed to ground, you can see it there as well. You just let the current flow. The current is going to cause heat at points, so whatever thing is consuming the power or letting the current flow is going to heat up. So that's one little trick you can also use this for, is basically let current flow through the circuit and heat something up to see it with a thermal imager. So hopefully you've learned something from this. I'm sure I've probably said some things not technically correct, and I'm sure somebody will correct me in the comments. It's a little hot today and I'm trying to get this done so I can go get some other work done. But if you like the video, hit the thumbs up, hit the subscribe. You can also go check out the other video of the Nissan that basically is one of my top viewed videos of how to find a short with a test light. I do a lot more testing in that video with some different circuits on that thing. And like I said, a lot of people still had a lot of questions about how I was doing it. So hopefully this was a very in-depth video to answer those questions. And hopefully you kind of understood it, because I wanted to go real in-depth about it. So yeah. Thanks for watching, everybody, and we'll see you guys later. Alright, so here's a little extra bonus footage. We have a junkyard replacement module here plugged up, and kind of still have everything set up the same way. Power going in through the bulb, going out through the current meter, and you can see that bulb is very dimly lit. And on the volt drop across the bulb, we can see that this bulb is consuming about 1.8 volts, and the total circuit current is less than an amp, about 750 milliamps for a good module. So if I actually take this right here and we'll bypass the bulb, you can see our current goes up to 2 amps. So no good module giving full power, full ground, consumes about 2 amps of current when it's just on, not doing anything. So there we go. That's pretty cool how you can use a voltmeter with your bulbs and a current meter and kind of just see how the circuit reacts.